So in this video, let's go ahead and review how to actually find the probability of a particular sample mean. And what we're going to do here is we need to decide first when we do any one of these problems whether we're talking about a mean or a proportion, and then whether we're talking about one mean, one proportion, or two means or two proportions. So when we read this problem, it says the Census Bureau has established that the mean income of heads of households in a particular city is $41,500 with a standard deviation of $18,700. A simple random sample of 100 heads of the households in that city indicates that the mean income of the sample individuals is $45,510 with a standard deviation of $23,156. Find the probability that a sample of this size will indicate a mean of $45,510 or more. So we see in this problem, for instance, when we start this, we already see that we're talking about means. Now, how many means or how many samples am I really talking about? Well, it tells me that I'm talking about one sample mean. And when I got that sample mean is sitting right here. It's $45,510 a sample mean. So when we start this, we go through a four-step process. That four-step process starts off like this. First step is I'm going to define the parameter. I also need to define the parameter. The parameter is a true value that comes from the population. It is the population value. In this case, I'm talking about the mean, so I'm going to talk about the population mean. We call our population mean mu. And he told us that in this particular city, the mean income for mu is this. So I define it in words first. I say mu is equal to, it's always going to be the true. It's the true something. This is the true mean income for heads of households of the city. For heads of households in this city. Now, once we have it defined, we can actually tell me what that value is. And that value here is mu is equal to $41,500. That's the population mean. Now that we have it defined, the second step is to state my conditions. Well, because it's a mean, there are three conditions. So we're going to check the conditions next. The first condition is that the sample that we're pulling it from is random. Population, we're going to pull our sample and make it random. And it states that in a simple random sample here. So the random condition is stated. And most of the time, your random condition will be stated. If not, though, we'll have to assume it. The second condition is that there is independence among the sample. And we show independence using our 10% rule. And so we'll say, surely, we have how many people in our sample? 100. So surely 100 people or 100 households are less than 10% of all households in this city. Now, another way we can write this, or we can, instead of saying the 10% rule, is we can look at it in terms of, well, 10% of what number is going to be 100? And so we can actually say, instead of saying it like we're writing, we can write it and say that surely there are 1,000 households in this population. Because 10% of 1,000 is 100. So we're saying that as long as there's 1,000 or more households, it also covers the 10% rule. So you can write it either way you want to. And then the third rule is the rule that we need for normality. And when we talk about means, the third rule is going to be based on either this problem's going to state that it's normal, or we're going to look at the sample size. And we look at the sample size, the normality check for a mean is going to be based on the central limit theorem. So our sample size is 100, so because n is greater than or equal to 30, central limit theorem focuses on the number 30. Because n is greater than or equal to 30, by the central limit theorem, I'm talking about the sample means, so I'll call that x bar, follows an approximately normal distribution. We know it's normal because of that. And so once our conditions are met, we can now go ahead and move to the next step, which is our third step is to actually state parameters for this. So this is different than defining the parameters, because when you state the parameters, you're going to tell me that first off, we're looking at the sample mean value, x bar. And when we do this, right, the next thing we're going to do is say x bar follows a normal distribution with a mean of the population. Well, we know our mean for the population, this value right here. And the standard deviation is going to be equal to the standard deviation of whatever the population is. Well, our standard deviation for the population is sitting right here. So we're going to take that value, but because we have a sample size now, we need to take that value and divide by the square root of the sample size. So we're going to take that 18,700 and divide it by the square root of our sample size, which is 100. This new value right here is called the standard error. And the standard error will always be smaller than the standard deviation, because the standard deviation looks at one value while the standard error looks at, in this case, 100 values. And so this simplifies to 1,870. So here are our parameters stated. We know now that the distribution for X bar, which is the sample mean, which is what we're looking at, follows a normal distribution. It has a mean centered at 41,500 and a standard error or standard deviation of $1,870. So the last part of this is, once we know all that, now we can actually calculate a normal probability. Here's your fourth step. So calculate a probability now. So because we know it's normal, our first goal is going to be to draw a normal curve. And we know in this normal curve, the mean sits at 41,500. Well, they asked about a X bar. Was equal to, or that was indicate the size of the mean will be 45,510 or more. So I want to find the probability of getting a X bar that is greater than 45,510 or more. That falls somewhere out here. And when I do this, I want to, or more means shade to the right, so I'm going to shade this to the right. And in my calculator, I'm going to use the function normal CDF. Lower bound here is 45,510. Upper bound, we need at least, there are 5 numbers here, we need at least 6 nines. The mean here is 41,500. Standard deviation is the new standard error that we calculated here, which is 1870. And when I calculate this, I get this equal to 0.016. So what this really means is that, based on everything I've done, to pull a sample of 100 people that has such a high mean, when the true mean should be 41,500, to pull this average sample right here, that only occurs 1.6% of the time.